Final problem that asks you to make your own graph. I'm going to again begin by factoring where I can, and that x squared minus 9 factors x plus 3, x minus 3. So for my vertical asymptote, my vertical asymptote happens where the denominator equals 0, and that's at negative 3 and positive 3. So another double asymptote kind of graph. Okay. Next I'm going to look for my horizontal asymptote. So again, I look at powers of x. Notice it's 2 on top, 2 on bottom. They are the same. So for the horizontal asymptote, I'm going to take their coefficients, 1 and 1, and divide them. So y equals 1. Okay, so there's our asymptotes in place. And then we're going to finish this with our point plotting. Okay, and that is again going to be calculator work to finish that out. So let's bring this on. I'm going to use parentheses around the top, x squared minus 2, parentheses around the bottom, x squared minus 9. I'm going to zoom standard to get my windows set back in place. And so what does it look like? It needs to have a curve up here. You can see that. It's going to have a curve right down here between these two, and it's going to have a curve up here. Now it's not enough to just know that and just slop some curves on here. I want real points. Okay, so we go into table. We get some real numbers that we can plot here, as best we can. So let's see, negative 4 is at 2. Let's change my table to go by halves again. See if I can get some better refinement. Let's see, negative 3.5 is at 3, a little bigger than 3, so that's kind of what I was wanting to see, that it's definitely going up right there. Down at negative 6, we're at about 1.25. So I've got a few points there, and those points are showing the curve. Okay, so there's that one. I'm going to look between the asymptotes, so I'm just going to look for some easy points to plot. Sometimes it's difficult to do. See, negative 2 is negative 0.4. Negative 1.5 is just about 0. See, 0 is 0.2, 2 repeating. It's above there. 2 is negative 0.4, so it just kind of looks symmetrical. Okay, so there's that end. I'm going to get the ones out here. And yeah, there's symmetry going on this side of the asymptote as well. So at 3.5, we're a little above 3. And then at 4, we're at 2. 6, we're at about 1.25. And so same curve as on the far left, on the far right here. And there's our graph of this rational function. Alright, finally I want to talk a little bit about limits. This slide says evaluate the limit based on the graph of f shown, or the limits. We've got a bunch of them here. First, let's recognize a few things about this particular graph. One, it does look like there's a vertical asymptote. Comes through the graph right here. And there's a horizontal asymptote coming through the graph like that. Now let's also notice real quick the scale on the graph. Negative 9.8 to 9, that's the x, so that'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9. That works out perfectly. So these are all counting by ones, etc. And then on the y's, notice it says negative 5 to 15. So the bottom of this graph is negative 5, which means we go to 0 next, which means we go to positive 5, which means we go to 10, and 15. Okay, so there's the scales, the window settings scaled out on the graphs. Alright, so we want to be able to evaluate these limits. Okay, the first limit asks as x approaches negative 3, and notice there's a little plus sign behind it. The little plus sign behind the 3 means from the right side. Okay, so here's negative 3 right here, so where this asymptote is, and I want to know what's happening to the function when we get closer to this line from the right side. This is the right side. And so get on the line. What am I doing as I get closer to negative 3? Right here. You can see that the graph's going up. It's going up towards positive infinity. Okay, number 16, this one says negative 3 with a minus behind it. That minus means just the opposite from the left side. Okay, so here's negative 3 again. Come from the left side, and as we come from the left side, this function is going down. It's going down towards negative infinity. Okay. The next one is asking us to find the limit as x approaches negative infinity. Negative infinity on the x-axis is here. It's way out to the left. So we've got to go to that direction. And as we go that direction, what's the function getting closer to? It's getting closer to that horizontal asymptote, which is at 5. And then so number 18, x is just simply approaching infinity, so positive infinity on the x-axis is to the right. So this graph is leveling out at 5. So these limits can be used to not only discuss in behavior like this, but also can be used to describe vertical asymptotes and horizontal asymptotes.